Okay, this video I'm going to go over the odd work and the answers, and then for the evens, I'll tell you the answers, but you need to justify. Okay, you need to make sure and then ask. If you can't justify the correct answers, you need to be able to come over to me and just ask so that we can solve by factoring. Okay, so the key with solving by factoring, we must have zero. So the first problem here, we have equal to zero, and this can be factored using the AC method. So the method that we use, this is my A, this is my C. Again, if it's not in that order, it's your job to put it in standard form of a quadratic. So you want your squared term, x term, constant. Okay, so I'm going to multiply 6x squared times 4, that's 24x squared. Okay, and we're going to come up with a combination of two numbers that multiply to give me the 24x squared, but then add up to a 25x. Okay, and my brain already found it. It's going to be 24 times 1. So I'm going to have a 24x. Order doesn't matter. And then a 1x. So if I had the x on this side, then the 24x doesn't matter. And the whole idea is we're going to replace that middle term with 24x plus 1x equals 0. Okay, this still equals 25x, but it allows us to then factor by grouping, which means we split it down the middle. On the left side, I have a 6x that's in common. So I want to factor out a 6x. And when I do that, I'm left with x plus 4 inside. And I like this technique because whatever is in parentheses on this side better be in parentheses on the other side. So in this case, I have to just factor out a 1. Okay, you always need something on the outside. So with the only thing in common is a 1, put a 1 there. And so here are your factors. 6x plus 1 times x plus 4 equals 0. Okay, now don't stop here. The whole idea of why we wanted to rewrite this in factored form, then I can see the answers. Okay, the answers is what makes these zeros, called the zero product property. What makes an x plus 4 0 is just a negative 4. Okay, negative 4 is a solution. Now, 6x plus 1, that's going to result in a fraction, but I would have to subtract a 1, so it's going to be a negative 1 over 6. Okay, and if you can't do that in your head, off to the side, set it equal to 0, and it's a two-step equation. Get rid of the plus 1 by subtracting 1, divide by 6, and that's where you get negative 1/6 from. Okay, so then just make sure you understand you should have negative 4/3 and a positive 8. Okay, you try that on your own, go through the same technique. For number 3, already in standard form, I'm ready to take AC. In this case, it's going to be a negative 42b squared, and we're not going to give up until we find a combination. And this is where, for some of you, you have to know your times tables. Okay, so if you don't know your times tables, use a calculator. Okay, I can start dividing. So I know 42 and 1, but I'm not going to be able to get a negative 11 out of that. You can try dividing it by 2. 21 and 2, one's going to be negative, one's going to be positive, but I can't get a negative 11 out of that. Okay, so I'll try then 3, and I see 3 times 14 is 42, and I can get a negative 11 if I make the 14 negative. Okay, that's the game we have to play. We have to find these pieces here so that I can rewrite this original quadratic so that I can do grouping. So I'm going to replace the negative 11b with negative 14b plus 3b minus 21 equals 0. I can split it down the middle. This side, so you have to make sure you factor out the GCF. So if you don't do this part correctly, it's not going to work out for you. So you have a 2 and a b that you can factor out, which will leave a b minus 7 in parentheses. I must see that b minus 7 on the other side, and it's really easy to realize that you need a 3 on the outside. Okay, 3b, and then 3 times negative 7 is negative 21. So again, we're not changing the problem, but once I get it to this point, what's on the outside makes up one of my factors, and then what's in parentheses that are on the same side, same exact expression, is your other factor. So again, it's always a good idea to, in your head, multiply this out so that you know this is equivalent to what we started with, okay? Has to be equivalent. And now I see my answers. I see positive 7's a solution and negative 3/2 is a solution, okay? I can do that in my head. Again, if you can't, set this equal to 0. Set each of these equal to 0 and solve 1 and 2 step equations, okay? This next answer for number 4 is going to be 6/5 and a 5, okay? Now, number 5, we don't have equal to 0. So this is the first problem where we have to get 0. So I'm just going to bring that 8 over by subtracting 8. So now I'm going to deal with this problem. So it's going to be plus 25 equals 0. 33 minus 8 is 25. Now it should be easy to factor. AC, this is a 50V squared that adds up to a 15V. My brain already knows I'm going to use a 5 and a 10, okay? 5 times 10 is 50. It adds up to 15. I'll put the 5V on this side, the 10V on the other side. Again, it doesn't matter. If you want your 10V first, put your 10V first. So on this side, I have 2V squared plus 5V plus 10V, oops, not equals yet, plus 25 equals 0. Again, you can never change the problem. I can rewrite it, but this still equals 15V. It allows us to split it down the middle. On this side, the only thing in common is a V. So I have 2V plus 5. Okay. I must have a 2V plus 5 on the other side. And hopefully you realize the GCF on this, what goes into a 10 and a 25 is a 5. And if I quickly distribute, I'm back to the 10V plus 25. So V plus 5 is one factor. 2V plus 5 is my other factor. And it's equal to 0. So then I use that zero product property. I know negative 5 is a solution. And I know negative 5/2 is going to be my other solution. Okay. Number 6, work it out so that you get 4/5 and negative 1. I want to see the work though. You're going to have to subtract that 8. Okay. You can't begin until it's equal to 0. Okay. For number 7, my suggestion will always be to make sure your squared term is positive. Okay. I want this to remain a 5m squared, but I still need 0 on one side. So I'm going to put this, I'm going to subtract, and I'm going to put it in the middle. I'm going to subtract negative or minus 17m. I'm going to put that in the middle, and then plus 6 equals 0. I'm sending what's on the right over to the left. Now I can make my diamond. It's a 30m squared. I need to come up with a combination that's going to be negative 17m. And again, I've been doing this so long, I can kind of see these numbers in my head right away, but it's going to take some practice for you. So ways of getting 30 to add up to a negative 17, I know it's going to be a negative 2 and a negative 15. Okay, so again, doesn't matter the order. I'm going to put my negative 15 and then my negative 2. Okay. It checks though. That's so important that make sure this multiplies to the 30m squared, but adds up to the negative 17m. So now I just have to replace the middle term, the negative or minus 15m minus 2m plus 6 equals 0. Split it down the middle, factor out my GCF, which in this case is a 5m. I'll be left with m minus 3 in parentheses. To have an m minus 3 on this other side, I have to factor out a negative 2. So just be careful. If you factored out a 2, you would be changing the problem. Negative 2 times m is negative 2m. Negative 2 times negative 3 is a plus 6. Okay, so it looks like 5m minus 2 is one factor. M minus 3 is your other. Set it equal to 0. Answers, positive 3 and positive 2/5. Okay, I have to add a 2, then divide by 5. Okay, when you do number 8, again, you need to send this stuff over. I would keep the 7b positive, but if you do that, you should be able to get negative 1/7 and negative 5. Okay, last problem, and I'll walk you through, then you have to make sure you have all the work. I want all 10 problems done. So make sure you understand it. Here, I'm going to subtract the 5 so that this is in standard form and equal to 0. Okay, so this one, numbers don't seem too bad. I get a negative 12p squared when I take a times c, and I need to make sure it can add up to a negative p. So again, my brain knows the numbers I'm going to use, but you're going to have to go through all the different ways. 12 times 1 can't use, 2 times 6 can't use, but a 4 and 3 can be used, where the 4 needs to be negative and the 3 needs to be positive. Okay, multiplies to give you the negative 12, adds up to the negative p. Again, it takes practice to get good at this, but it's good exercise for your brain. And we're going to split this down the middle. On this side, the only thing I can factor out is a p, 3p minus 4. When you get over to this side, the only thing that's in common is a 1, but I will have the 3p minus 4. So I feel good about that I factored this correctly. Again, if these don't match, I made a mistake. Okay, so there's no way you'll get the correct answers then. So 3p minus 4 equals 0 is my other factor. So then my answers, what makes this 0 is a negative 1. And then you add a 4 and divide by 3, and you get 4/3 as your other answer. Okay? Therefore, number 10, just so you can justify, you need to get a negative 2/7. You need 0. So send all this stuff over. And then the other answer is a nice 3. Okay? So that took 12 minutes to be able to do. Please practice this. Get good at this. It's good exercise for your brain. It's going to help you in a lot of areas of what's happening later on in this course. So make sure you're good at factoring and understanding how to break up the numbers. And hopefully you're only going to get better at this as time goes on. Okay, thank you for watching. Please make sure you reach out to me if you have any questions. Take care.